Okay, so our last session today, we're going to be talking about another data management structure, which we got a little sneak peek into with some people's code during the Blackjack session, which is dictionaries. Um, so dictionaries are another way of storing information in Python that's a little bit more organized and allows you to access information without having to know the exact index of your list, for example. So there are functions that allow you to search through lists and things like that, but in general, you still need to know which index the value is sitting at that you need. Dictionaries are a way of tying information in a list to specific values so that they can be retrieved kind of regardless of where they're sitting in the dictionary. Um, so dictionaries store pairs of data. Data is stored as a key and a value. So on the right here, we have an example of a visualization of a dictionary. These are grades for students, not real students, obviously. Um, but if you were to store grades in a grade book, you might use a dictionary to do it. And you can correlate the information with a name. So you create a custom index, which is your key, and then that index has a value element um, associated with it. And these are created similarly to lists and tuples. They're a little bit different um, in that you can create an empty dictionary if you'd like and then start adding to it. You can do the same thing with lists, by the way, if you just specify. Um, let me share my whole screen again. Oh, I lost my actual idle window. So for example, we were talking about lists before. If you just do L1 equals empty brackets, this is something I forgot to talk about. You can create an empty list and then it'll print out with nothing. And then you can use our append function like we talked about to start adding things in. Um, Same thing with dictionaries. You can create an empty dictionary and then store values in after the fact, or you can create it with some initial information. And this is the syntax for how you would do that. So grades equals curly brackets. So dictionaries are represented by curly brackets in Python. And then in this case, we want our key to be string. And then we're going to associate it with a value by separating them with a colon. So that's our first pair of key and values. So that's key one, value two. Then we'll do John. John got an A plus. He's doing great. Denise, A. And then Katie, A. So go ahead and make that. And then if we print grades, we'll see it prints much the same as lists and tuples. So one thing you'll notice here, we'll talk more about this in a minute, is that our keys are all unique. Our values do not have to be all unique. That is a property of the Python dictionary. Each key must be unique, but the values associated with each key do not have to be. They can be repeated. So similar to indexing into a list, you index your variable name the same way that you would a list, where we would say grades and then John. So let's say we forgot John's grade. It prints out A plus. You'll notice you still use the hard brackets when you're indexing into dictionary, but when you're creating it, you have to specify it with the curly brackets. The key is not found, you'll get a key error. So if we do grades, and then in this case, Sylvan is the example name. Need this to be plural. You'll get a key error, which means that it cannot find the key that you've tried to index to. Pretty straightforward. Similar to a list, you can add entries to a dictionary. But here we have a built-in method. So say we did want to add Sylvan to our dictionary. We would say Sylvan gets an A. Let's give Sylvan a C. It's too many A's in this dictionary. Now when we print grades, we should have Sylvan added to the end there. So this works the same way that append works in a list, but we're actually adding it to the end of the dictionary. And again, because order doesn't matter in a dictionary, even though it's being added to the end, it can still be referenced the same way. Dictionaries are kind of agnostic to the order of things. This is for looking things up that are specifically tied to a key. So now if we do grades, Sylvan again, we should get C. If you're not sure if a key exists in a dictionary, you can test for it. The syntax for that is John in grades. And if it is there, it'll say true. If it's not, it'll say false. So Daniel's not in grades, so it gives it false. So if, before you test, if you want to try to avoid this key error situation, you can have it return true or false values. So you can set up if-else statements with your dictionary to say, is this in the dictionary? And if it's false, then you go do something else instead of, crashing the software or the program, I mean. To delete, there's actually a dedicated delete function. Grades. We'll delete Anna. And now when we print grades, we'll see that it's removed Anna from the front. And again, we'll do, so as another example, talk about this with a list, we would need to know exactly which index we were trying to remove. In this case, we don't need to know the order. We just need to know the name of the key. So in this case, we could delete Katie from the middle of the dictionary without having to know where Katie's value actually is. So now when we print, we can see that Katie's been removed. So this is actually searching for a specific key. Keys don't have to be strings. They can be numerical values. But the key itself is what's always being looked up, and then the value is reported. So in our deck of cards example for our blackjack problem, how would you set a dictionary up to represent the values corresponding to different cards? Yep, Troy says face cards equal a value of 10. So we could do, I won't do all. But the idea here would be 2, 2, 1. Then you would have, obviously I can't put this in my code normally, just as an example. Then you could do Jack and give it a value of 10. Queen, give it a value of 10, and so on. Right. All right, so you can also, for more dictionary operations here, you can get an iterable that acts like a tuple of all the keys. So we can say grades dot keys. And again, this is a function that's being applied to our grades dictionary. And then it'll return the keys that are currently in the dictionary. Mine's different from the example here because we removed a couple extras, but if you're not sure which keys a dictionary contains, you can search that way. You can also do the same thing with values. And it'll return the total number of values. Now, keep in mind, there's no guaranteed order for how these get reported. This is just giving you a list of all the possible keys and all the possible values. In this case, we have returns of the same length. If we wanted to add, let's say add Katie back, do grades, Katie equals A. Now when we do grades.keys, we'll have a list of 4, but when we do grades.values, we'll still have a list of 4. It just prints all the values out, it duplicates. Okay. So values, again, can be duplicates. They can be immutable or mutable values. Dictionary values can even be lists or even other dictionaries. So you can have nested dictionaries like we did nested lists earlier. But keys must be unique. They have to be an immutable type. And it's recommended not to use floats as keys, just because they're a little bit more complicated to hash. So it's recommended to use integers, strings, or even tuples. But the core idea is that it has to be something that is immutable. It can't be changed without overriding the value. So summary: list is an ordered sequence of elements. Dictionary matches keys to values. Look up elements in a list by an integer index. Look up item by another item in a dictionary. We talked about all this. The reason why this is important is that when we get to using CompuCell, the way that CompuCell tracks all of its cells in the simulation is by using a cell dictionary. So when you start getting into the nitty-gritty of CompuCell Python towards the end of the workshop, it will be important to understand kind of how CompuCell manages cells within its dictionary. We'll talk a little bit about that during the workshop itself. So let's do a quick exercise with this. I'm going to actually skip the words one because we need a data set for that. So let's do this one, character counting. So write a function that returns a dictionary with the number of occurrences of each character in a string. So I'll put a few minutes on the clock, give people a chance to get their head around that a little bit. And then I'll start working through it on my end here in just a minute. Questions so far? Anybody have code to share? Realized I was not sharing the PowerPoint. Okay, got Yash. Let's take a look at this. Zoom really doesn't like maintaining formatting for me. Now let's see. Yep, looks good. And then if I make this a IOU again, and then maybe OU. Yep, looks good. Yeah, Micah. Yep, basically the same thing. Yeah, sorry, that wasn't clear. I added an extra O and an extra U. So it's AIOU twice and then OU three times. All right, looks good. Anybody else have a different approach? Yep, looks like Tapanjan, very similar. Good. Okay, so we can go ahead and move on then. So, any questions about that? People want 5 more minutes to work on the example. I know people are probably getting tired. It's been a long day. Okay, so in that case, any questions about dictionaries? Again, you don't need to be a dictionary expert. It's just kind of important that you see them before we start talking about the cell list in CompuCell during the workshop. Okay, so if there's no questions about dictionaries, again, feel free to put them in the chat, email them to me later. There is this other activity that we had for converting lyrics to frequencies. So if you start with a word list, take some song lyrics of your favorite song, then parse them into a list, which is actually commands for you can take a text file and have it be delimited by spaces and put each word in a list. Then you can turn that list into a dictionary and count the frequencies the same way we were doing here. Okay, so I think that's it for dictionaries. So our last topic of the day then is going to be talking a little bit about objects and object-oriented programming and how they work. This is probably the most abstract topic of the day, but again, it is important to understand because this is how CompuCell cells in your cellular simulations inherit their properties from parent cells. Um, so like we talked about at the beginning of the day, Python supports many different kinds of data. Each type of data is an object, and every object has a type, which is an internal data representation, um, and a set of procedures for interacting with that object. Um, so for example, when we were looking at individual integers before, something like 1234 is an instance of the integer type. So 1, 2, 3, 4 is an object of the class integer. We'll talk about classes in a minute. Hello is an instance of a string. So string is the class, and hello is a specific instance of a string. So every time you create a variable like an integer or like a string, you are creating an instance of a class which has been defined elsewhere. And that class has specific data types and specific procedures for interacting with it built into the class. So we can create new objects of some type, we can manipulate those objects, and we can destroy objects using delete or just stop using them. Python will eventually reclaim things that have been destroyed or are no longer accessible. It takes care of that on the back end for you. Nothing we do will be so complicated that we really need to worry about memory management like that. But yes, anything that's been deleted, don't have to worry about getting rid of. There are some languages like C where you have to make sure that you're managing your memory on your own. It's one of the reasons why C is notoriously difficult to learn. It's a lot of things that you can forget to do that can mess your program up. Python, luckily, handles all of that for us. So again, objects are a data abstraction. They capture an internal representation of the object's data and an interface for interacting with the object through built-in methods. So the things we were using before, like a list, is an instance of the list class, and the methods like append and pop and remove, these are all built-in methods that have been written into the class. And every time you create a list, it automatically has access to those functions. So here, for example, 1, 2, 3, 4 has type list. It's represented internally as a linked list of cells. So this is your sequential 1, 2, 3, 4, index 0, 1, 2, 3. And then it has all these built-in functions that allow you to manipulate this internally linked list of cells. So you can create and use your own types with classes. So this is what sort of defines a data type, is creating a class. So you have to define the class name, the class attributes, and then the methods that you use to interact with it. We'll look at a couple of examples. We won't do any long drawn out exercises with this today because it's not super important that you know how to write custom classes yet. But it is important to kind of understand how these things work for when you're debugging your CompuCell code during the workshop, and during the hackathon especially. When you're creating objects, there's inheritance hierarchies. So there's the parent class, which is the superclass, and you can actually make other classes below it that have the same properties, but maybe additional ones. So when you create a child class, it inherits all the data and behaviors of the parent class, but then you can add more information to that. So for example, if you had the class cell when you're working in CompuCell, a cell would have a certain amount of inherent properties. But then you might create a child class called tumor cell or cancer cell that has all of the properties of a normal cell, but it also has these additional properties and behaviors that you can put on top, that the parent cell class doesn't have. So this is a way for you to basically create data types that might be reused a lot that have common foundations, but allow you to make modifications to additional class types. So you don't have to specify everything every time. And you can even override behavior from the parent class in the child class. So there are commands that allow you to say, it's going to have this data attribute that it inherits from the parent, but I want it to behave differently in this particular child class. So for example, in this case, these arrows are actually backwards, I think. But the idea is that you would have a class animal as the parent class, and then within that you would have child classes of person, cat, and rabbit. They all inherit certain types of properties. Like maybe they all have homeostasis, or we all have eyes. Um, and then when you make these child classes, you need to modify, how those eyes work, what they do, how the homeostasis works. And then again, you can do another child class from person. Student inherits person, which takes all of the properties of animal and person, and now you can add more to student. So this allows you to basically create class structures of inheritance so that you can reuse properties that are common among multiple things. So we can define our own types by using the class keyword. And I'll just kind of walk through this because I know we're getting close to um, the end of our session here at 4:30, and I want to leave some time for questions before 5. So we'll just take a look at this and kind of explore it conceptually instead of walking through these examples because they can be a little bit complicated. But again, we will provide some sample code for these examples for people to look at over this week if they're interested in learning more about classes. I'm getting notices that my internet connection is unstable. My Zoom does that sometimes if I've been going for more than an hour. So hopefully I'm not blipping in and out. If I am, please let me know. Oh, good. Okay, cool. So you can create new classes. So in this case, we want to create a coordinate, like an XY coordinate, which inherits from object. So when you're creating new ones, you have to have this parent class of object. Means that it's a Python object and inherits all properties of a basic Python object. So this is kind of similar to how we define functions, except instead of defining a procedure that a function performs, um, we're defining properties of an object. So attributes are data that belong to the class. So a coordinate is made up of two numbers, x and y. So you would need to have either integers or probably more realistically, two floats associated with the class for your x and y values. How would you interact with this object? You might have x and y associated with the class. So you would have maybe a set function that allows you to set the x value and set the y value. Maybe a print function that allows you to print the x and y value. Maybe even something that calculates the vector from an origin of that coordinate point. A number of different things you can do, but these are all specified within the class structure. So here's an example of our coordinate object. You use this special method called initialize, to initialize data attributes. So in this case, we would say class coordinate object, define init, and then here self refers to the instance of the class. So the self function just says for this object that's being created, we need an x value and a y value. And then we set self.x to x and self.y to y. This seems a little bit strange. Why do we need these additional things? But what this allows it to do basically is that when you create an instance of an object, self is replaced with the variable name that you give it. When you're creating the class, you need this self value to say, whatever this object is called, here's how we're assigning the values. And then when you create an instance of the class, so here we would do C equals coordinate 3 and 4. So it takes in two parameters, x and y. And then when you create the instance of the class, what's happening is we're saying C equals coordinate object with parameters x and y refers back to this class function, coordinate object. What's happening here is C is self, and then it's taking in x and y, setting set c.x to x and c.y to y, the values that you provided when you instantiated the object. And instantiation just means creating a space in memory here and assigning it to a variable. You can create another coordinate object called origin, give it the value 0, 0. And then you have these functions where you can print directly from an instantiated object to say, all right, I need to know what the x value is of our coordinate. So you would say c.x, and it would print out 3. Questions about that so far? Again, we can work through an example in a minute here if there's time. I just wanted to show you this before we wrap for the day. Yes. Yeah, in a minute here, Dipanjan, we can actually walk through this. I think we'll have a few minutes to look at we can do it together. Look at the coordinate example. So a method function that works only with a specific class. Similar to attributes, the dot operator is used to access these methods. Similar to how we define the data, you can define a function within a class the same way we were defining it just sort of arbitrarily before in our Python files. And then when you call this function, so you would say origin.distance, then it would run this definition. So yeah, we'll build this up in a document in just a minute. This is just how you use the method. Okay. So I think we've got time. Let's actually back up and do this then. Sounds like it'll be useful. So let's go ahead and make our coordinate class. And then we'll do self.x equals x, self.y equals y. So Anastasia asked a good question. What's the difference between methods defined with the underscores like this? What that's doing is it's overriding inherited properties from the object class. So when you make a new class, everything in Python inherits from object. That's the most basic class you can have in Python. Every object has an initialization function built in. That's what the init is. And we have to say when we're creating a new class that we need to overwrite the initialization to change the properties that come in. So this underscore init underscore is saying that like the parent object has an initialization function, but we wanted to do this instead. How can you see which functions are inherited for a given object class? That's actually a good question. I don't know if there's a command for that. Usually that kind of stuff is provided by the developers in the API for the specific things that you're looking for. That's kind of more of a job for documentation than, I mean, you can obviously look at the code itself as well, but the easiest way is probably to find the documentation there. If somebody knows of the way that I'm not familiar with, please feel free to share. But classes start to get a little bit esoteric, and it's not as easy to just say, print out what it can do. You also start getting into when people are writing these classes. So when we were doing import random before in our blackjack example, that was importing another Python file that has all of these specifications for the random generator class. So that's another reason why it gets a little bit tricky to start printing stuff out because you're referencing usually other documents that are pulling in information, and um, that's why it's kind of left up to the documentation. So we've got our class here of coordinate object that creates an X and Y coordinate. So we would say C equals coordinate. We'll mess around with this in a minute to make the example useful instead of just retyping what's in the slides. Just want to get it all down here. So let's say we print C.x, print origin.x. Let's run that. Sorry, I've got a syntax error here. Yep, that was it. Thank you. Show it the slide. So here we've got an error. Line 6 in module. Type error, coordinate, takes no arguments. Ah, good. Yep, double underscore was the problem. Thank you again. You guys are keeping me on my toes today. We'll get through this together. Yep, so we see here now when we run it. So we do need double underscores. That was my fault again. The slides are, this is probably a double underscore. It's hard to see. But when we print our values, we get 3 and 0. Um, One thing we can also try, what happens if we just print C? You'll see that when we have a basic print statement, we get our memory index. So this is the default print behavior for a Python object. If you want something specific to happen when you run print on our coordinate class, you have to override the print command that's um, in Python, or sorry, in the object class. So if you run a print on something and this is the kind of output you get, it means that whatever data type you're looking at has not replaced the print command with something specific. So let's go ahead and add to our code our distance function. So this time we don't have to use underscores because this is going to be a unique method for this class. It's not inheriting anything from the object class. This is new. self.x minus other.x 2 self.y minus other.y, and then we return. Plus y underscore difference squared. So here we're representing our distance equation, which is the difference between the x values squared and the difference between the y values squared added together in square root. So now we have our c coordinate and our origin coordinate. And what this is doing, oops, sorry, I have a period here, that should be a comma, is the distance argument is taking in it's going to take in one coordinate value. The reason why it has 2 here is because it's applying it to the self. So whatever coordinate we want to determine distance from, we'll do origin. So for example, if we wanted to know the distance between origin and C, we would say origin dot distance, take in parameter C. So this is going to be other. So this is taking in a coordinate object. X difference squared self.x, so the value of the one that the method is being run on minus the value of the other coordinate object's x value squared. Same thing for y. And then we return the sum. So let's save that. So we've got print c.x. So we'll say origin dot distance c. And that didn't do anything because I didn't print it. Sorry about that. There, now we should get our distance value. And in the interest of time, I won't check the accuracy on that, but we do get a float, which means it is converting it based on our various values, because we have a float here in our square root. Okay. Yeah, so we do have a slide here on print representation of an object. You can define the string method. So let's go ahead and do that now. Let's say we wanted to print the actual coordinates and not the memory and location, or the location and memory, excuse me. So we would say define string self. And the order that you put these functions in doesn't matter because it will, when it's called, it will go find it in the class definition. So we'll say return, and then we can build up a beautified version of this. Remember, we do have to cast our data type because it's going to be coming in as an integer value or float, however you defined it. So we wanted to cast as a string so it'll concatenate properly. Then we can add a comma. Then we can do string again, cast self.y plus closing bracket. And again, what this self dot is doing is just referring to the instance's own internal X and Y values to print that, regardless of what you've called it. So now we can say print C, print origin. Run this, we should now get our customized print statement instead of our memory location. Is that going to help illustrate things a little bit, Dipanjan? Again, it's okay. Some of this stuff starts to get a little bit abstract, but like I said, it's mostly important just to kind of understand how this works, because when we start doing CompuCell code, you'll see that we start overriding some of these inherited properties. So we have a few more slides here, I think in the interest of time, because we're running up on our Q&A period. Okay, good. I'll leave this to you to continue reviewing if you'd like. And there's special operators. So again, you can review the slides, and there is good documentation on this through Python's tutorials, various things that are built into the object class that you can override. But basically, this allows you to build layers of object abstraction. So if you want to have class definitions for various cell types, for various behaviors, but you want them all to have the same basis, you can do that. And that way you know that all of your cells are using kind of the same fundamental instantiation, or excuse me, data attributes. And the only thing that differs is their specific class behaviors. So any further questions on classes? I know that was a very quick overview, and this stuff can be very confusing and gets complicated when you start doing your own class definitions, but that was what I had for today. So we are at the end of our time. I think what we'll do, I was planning on spending a little bit of time today talking about looking at kind of how Python looks in CompuCell. I think what we'll do is on Monday, I will try to record a brief video overview of that. And publish that to the CompuCell YouTube page, and I'll send a link out when that's ready. That way you can kind of get, and again, we do look at this in the first session of the workshop. We look at kind of how the Python and XML are structured in CompuCell. But I can record a quick 5 to 10 minute overview of CompuCell Python. And once people have had a chance maybe to review some of the stuff from today's session, you can take a look at that and get a feel for what we're looking at in terms of Python with CompuCell. So I'll give people a few minutes for questions here. I am going to relaunch the module poll. I know this was a short one, but we do still want to get that. I need to grab the results from our current poll first. If people have questions in the meantime, happy to answer them. Sorry, I did see, could you just quickly return to your input for the current output? Yes, absolutely. I can split screen that for you. One other thing to mention about classes is now that we have all of this, what we can do, just to kind of illustrate kind of how some of this stuff was working, we want to make a new file. We'll call this coordinate.py. What we can actually do is copy this class definition into our coordinate file, save that, close it, and then as long as we're in the same directory as our coordinate file, we can say from coordinate import star should, yeah, get the same output. So you can actually save your class definitions in a separate file and then import them into your actual script document, and it'll run the same way every time you call one of these functions or you create a instance of the class. It will say, okay, I need to go look at the coordinate.py file. And again, that has to be in the same directory. So as long as you're in the same directory on your computer, it can see it. If you put it in a different one, you'll have to specify the path when you import. Um, okay, and like I said, I'll make sure I put all these files up in the um, student materials folder along with our Python stuff. All right, so let me go ahead and relaunch very quickly for those who don't have to rush out of here just yet. Let me go ahead and relaunch this poll. Stop sharing for just a second. Sorry, my screen is getting very complicated here. Okay, I've gone ahead and relaunched the module experience questionnaire. If you could take just a minute to fill that out. And then if you have any questions, I'm here till 5 o'clock. If you do not have any questions and you've already filled out the poll, then you are free to go and enjoy what's left of your Saturday. And I will be in touch kind of at the start of this week with some more announcements about final prep for the workshop. And then we will get started on the 28th. So I look forward to seeing all of you there. And again, I am here. I can stay here for another 20 minutes or so for Q&A if you have specific questions or if you want to look at an example together. Happy to do that. I am going to run to the restroom very quickly, though. I'll be right back. Okay. Any questions either about what we talked about today, or if you have any other questions about the workshop or hackathon, I'm happy to talk about that as well. Hey, Ronak, I see you're still here. Did you ever get CompuCell installed? I know you were having trouble in the first installation session, I think. Guess I'm remembering somebody else. You can reply in the chat if you're still there. Yep. Thank you, Troy. Thanks for coming today. All right. Ronak, did you have any other questions or were you just finishing up the poll?
Looks like everybody's answered the poll.
Yeah. Well, so it's sometimes the optional questions, like the text questions, take longer to update.
It says 20 of 20 participated.
Yeah, that's if they participated in any question though,
I
at the
see.
top. So he may still be filling out some of the short answer ones.
Misleading.
Yeah, we learned that the hard way last year because we kept getting excited. We were like, such good participation, and then realized that people ran out of time and
That's really,
didn't
yeah.
stop recording.